Geography 411 Introduction to Geographic Information Science Lesson 5, Lecture 2 Boolean Algebra Learning Outcomes. In this lecture, we will review the common Boolean operators which you probably have learned in high school or college, and we also review some common properties of those operators. But the most important thing is, at the end of this lecture, you should know how and where to use the Boolean operators in GIS. Boolean algebra. Boolean algebra is a branch of algebra in which a variable may have the value of true or false. And for the purpose of arithmetic operations, true is represented by number 1 and false is represented by 0. For that reason, it is also called as binary algebra or logical algebra. And Boolean algebra is the type of algebra that is often used in computer programs such as search engines and in general in analytic reasoning. Within ArcGIS, Boolean algebra is used widely in select by attribute on both vector and raster data, and also used in select by location on both vector and raster data. Types of Boolean operators. There are three basic operators in Boolean algebra. They are AND, OR, and NOT. However, in GIS, we also often use the XOR operator, which is an exclusive OR operator. Using these operators, Boolean variables may be combined into formulas for more complex propositions. We will go over each of those four operators in this lecture. Boolean operator AND. With the Boolean operator AND, the statement A and B is true only if A is true and B is true as well. And in GIS, the operator AND narrows the search by instructing the search engine to search for all the records or features satisfying the first condition, then for all the records or features satisfying the second condition, and show only those records or features that contain both. And on this slide, you see a couple of examples for the Boolean operator AND in the select by attribute. For example, you want to find all roads which are paved and also all roads which are longer than 1 mile in Knox County. Another example is for select by location. And here you want to find all roads which are within, let's say, 500 feet of a school and also have a park within the 1,000 feet buffers, etc. Some common properties of the Boolean operator AND. The commutative properties. The commutative law states that changing the sequence of the variables does not have any effect on the output of an AND Boolean operation. For the associative properties, the law states that the order in which the logic AND operations are performed is irrelevant as the effect is the same. On the other hand, for the distributive properties, the law states that for a combined Boolean operations of an AND operator on another OR operator, you can do it in a distributive fashion and the effect is the same. The Boolean operator OR. For the Boolean operator OR, the statement A or B is true if either A is true or B is true, or both of them, both A and B are true. And the operator OR broadens the search to include records or features which satisfy either conditions or both. For example, with select by attribute, You want to find all roads which are paved or half paved in Knox County, or you want to find all roads which are within 500 feet of a school or within 1,000 feet of a park, etc. Common properties of the Boolean operator are similar to the Boolean operator AND. The Boolean operator OR possesses the commutative, associative, and distributive properties. The Boolean operator NOT. The statement not A is just the opposite of A, and the NOT operator excludes the unwanted records or features from the search. For example, you want to find all roads which are not paved, or you want to find all roads which are not within 500 feet of a school, etc. The Boolean operator XOR. The statement A XOR B is only true if either A is true or B is true, but not A and B are true at the same time. In other words, one is true and the other is false. So, in other words, one or the other, but not both. For example, you want to find all roads which are paved XOR half paved in Knox County. That means if you have a road classified that both paved and half paved, then that road will be excluded from the search. Common properties of the Boolean operator XOR are different from the Boolean operators AND and OR. The Boolean operator XOR only possesses the commutative and associative properties, but not the distributive property. So you might want to be careful in applying the XOR operation in a distributive case. Example 1. Assume you have a polygon layer of land cover tracts with 7 different land cover types, including agriculture, forest, barren land, brush, built up, wetland, and water. Your task is to design a set of Boolean operations to select all of the agricultural tracts which are adjacent to forests or next to the built-up tracts. In this case, you should go with the spatial select or select by location. I will go over this example during a meeting of Quick 5. Example 2. The data used for example 2 is similar to those in example 1, but the task is a bit different. And your task is to design a set of Boolean operations to select agricultural tracts which are adjacent to forests and not next to the built-up tracts. And again, in this example, you should go with the spatial select. Reflections. After viewing this lecture, I'd like you to do some exercise. So please do some Boolean operations with your GS project data, and then post them, the result and your Boolean operations on your wiki page, and comments on those analyses, also the result.